Hey guys, so today's paper is about BERT. Presenters are me, Karan, Asad, Ashwini, and Akash. So, ever wondered how computers actually understand human language? For the longest time, it was nearly impossible, but then BERT changed everything. For us, this is obvious. Riverbank or bank? What's the difference? One's about water, the other's about money. But for a computer, bank is just letters. The secret is context. Understanding context has always been AI's biggest challenge. The words around bank tell us what it means. Here's the problem with early AI: tunnel vision. Humans read whole sentences at once, but early models could only process from left to right one word at a time. This unidirection thinking put a ceiling on what AI could achieve. It's like solving a puzzle while only seeing pieces you've already placed. ChatGPT was powerful, but information only flowed one direction. A word in the middle had no clue what came next, a huge handicap. And the solution to this? BERT. It built a two-way superhighway. The name says it all. Bidirectional encoder representation from transformers. It looks both forward and backward simultaneously. BERT sees the entire sentence at once, letting every word understand its context from beginning to end. But training was tricky. If BERT sees everything, how do you teach it without cheating? Well, there were two brilliant methods. First, randomly mask 15% of words and make BERT predict them. Second is to show two sentences and ask if they actually connect. Simple but effective. The result? Revolutionary. As the paper said, conceptually simple and empirically powerful. BERT scored 80.5% on the Glue benchmark, a 7.7% jump over OpenAI GPT. In AI research, that's not a step forward, it's a giant leap. Looking, looking both ways was simply better. BERT set new records on 11 different language tasks in one shot. And the legacy? BERT proved bidirectional understanding is essential and created a new standard. Pre-train one massive model and then fine-tune it for any task. It kicked off a new era. Now that machines understand our words, what will we help them achieve next? Well, to dive deeper into the architecture of BERT, we have Asad. Thank you.
BERT stands for Bidirectional Encoder Representation from Transformers. The main idea of BERT reads the whole sentence at once, both from left to right and right to left. Because of this, it understands context much more accurately than earlier model processed text in one direction. BERT has input token that gets converted into three embeddings: token, segment, and position embeddings. These are later added together and transform the process in a fully bidirectional way. The bot prepares its input in a sequence that starts with a special CLS token and ends with SCP token. It has two sentences, but packs them in a single sequence and uses segment embeddings to mark which token belongs to which sentence. Bot is pre-trained using two tasks. The first, that is mask language modeling, and the second, that is next sentence prediction. Mask language modeling is a token that are masked and the model learns to predict them using a surrounding context from both sides. And the second task, model sees two tasks and predicts whether the second actually follows the first or not. After pre-training, there is a process of fine-tuning that is very simple. Example, we take the same bot model and add one small task-specific layer on top, like which will behave as a classifier or span predictor. Then the entire model is trained end-to-end on a much smaller data set, which tells us to get a new approach to a best result on NLP benchmarks. Overall, the combination of BERT architecture is one of the most influential models in natural language processing.
Now that we have understood how BERT is built and trained, but the real question is, did all of this actually pay off? A strong architecture is one thing, but proving it work across real-world language tasks is what truly matters. The author did not depend on just one benchmark. They tested BERT across multiple challenging evaluations, each measuring a different skill, like testing a student in reading, comprehension, reasoning, and logic all at once. That's where Glue, Squad, and Swag come in. Glue check the general language understanding, Squad test precise question answering, and SWAG evaluate common sense reasoning. Before BERT, even the best models struggled across these tasks. So this section really answers how capable is BERT actually. Let's start with Blue, a collection of 9 tasks, including sentiment analysis, natural language inference, and paraphrase detection. It's one of the broadest tests of natural language understanding. Before BERT, OpenAI's GPT led with score of 75.1. When BERT arrived, the improvement was immediate. BERT base scored 79.6 and BERT large reached 82.1. A few points may seem small, but in blue they represent thousands of correct predictions. And importantly, BERT did not learn these tasks separately. It learned one powerful representation of language during pre-training and then fine-tuned the same backbone for each task. This was the first clear proof that bidirectional training was not just theoretical, it was practically superior. Understanding text is one thing, but applying that understanding is another. That's why Squad is such an important test. Squad gives Bert a paragraph and questions, and Bert must extract that exact answer span. Not guess, not summarize, but choose the correct word. Bert reached 93.2 F1 on Squad version 1.1 and 83.1 on the more difficult version 2.0, which include questions with no answers. This shows a bird isn't just confident, is careful, knows when an answer does not exist. Then there is a SWAG, which tests everyday reasoning. Given a situation, bird predict the most likely next event. Bird scored 86%, beating GPT by 8 points. Since SWAG is designed to detect shallow pattern matching, this result shows that bird genuinely model context and meaning. So, all of this benchmark, what do we learn? First, bidirectionality works. Second, pre-trained once, fine-tuned everywhere is extremely powerful. And third, scaling matters. These three ideas together explain why BERT did not just outperform previous model, it set a new record across 11 major NLP tasks. And that's why the experiment section of this paper is so important. With that, I will hand it over to the Akash.
Hello everyone, this is Akash. I'm gonna walk you through the key ablation studies from the BERT paper and the main conclusions. So the goal here is to see which part of BERT actually matters and how each choice affects its performance. So basically, what are ablation studies? It is to test a model by removing or changing one component at a time. So with BERT, these experiments help reveal which design choice, like masking, centers prediction, or bidirectionality, are actually responsible for its strong results. So the first experiment is by removing next NS prediction. So when they removed NSP, performance dropped a little all across the model, which means NSP is in the main core of the BERT, but it does give the model helpful information for tasks involving pairs of sentences. And the next experiment is by replacing MLM with left to right LM. So this shows the significant insights. This confirms that the BERT strength comes from learning with bidirectional context, which normally left to right models can't capture. The next experiment is by adding by LSTM on top of LTR model. So they also tried fixing the left to right model by adding a bidirectional LSTM on top, but it barely helps. This proves that bidirectional understanding must be learned during pre-training and not added afterwards. And here comes the effect of pre-training steps. So training BERT longer from 500K steps to like 1 million steps adds about a 1% improvement. This might sound a little, but in this case, it is a huge significant leap. It shows that the scale and training time directly boost BERT's language understanding. And next comes the effect of masking strategies. BERT's masking strategies, like mixing masks, same and random replacements, turned out to be more stable. Using only mask or random tokens hurts performance. The mixed strategy avoids mismatch between pre-training and fine-tuning. And here we come to the conclusion. So overall, the ablation results make it clear that BERT succeeds mainly because of two things. Its bidirectional mask language model and its large-scale pre-training. These choices let the same pre-trained model adapt extremely well to many NLP tasks with just a little fine-tuning. That's what made BERT a major step forward in natural language understandings. Thank you. Hope you all understood the concept.